Alright, today in the shop we're going to be doing a 33 Nosler for a long-time customer. His name's Tim Sargent. I never do complete builds, always basically just barreled actions, but he sent me all the plunder to put it together. So we're going to get started. We got a Defiance Classic Action, 33 Nosler Reamer obviously. I got everything drawn up in the computer. We'll move there in a second. We started going a little smaller on our pre-drilling. Just makes a better chip flow, puts a little bit more load on the reamer to keep her still. Obviously our Omni reamer holder. Wilson blank. We do all of our chambering prior to contouring. Just works better for our flow. And we'll move over to the computer and show you what we're doing there. Alright, so I don't know how many of you guys have ever played with Fusion 360 or done any CAD or CAM modeling, but the course I bought was all about drawing it out with lines, connecting them, and then revolving them. Recently, I started doing everything with 3D drawing, so everything starts out as a model, and that's really helped me so far, so I can just make small tweaks without reinventing the whole model. That's what I struggled with. So our processes, and you'll see it on the machine once we get to operating it. I do a facing operation, a profiling operation. I install manual tool changes. The reason I do that is if I don't, the computer program will just keep going, and if I need to take off another thou or two on a finish pass, it would have to run the whole program in the code. So I put in a manual tool change that just prints code that says I can start there. If I didn't, this program would just keep writing. We do a threading pass, then I top it, and then I do a cleanup pass. We drill, we do our chamfer, goes all the way in, bores it. Then I do a finish pass, pushing the chip back. And then I come and do a finishing pass, pulling all these chips out in case we have any chatter or squeals or anything. Just gives a nice finish. And then we start our reaming cycles. I do 3 different reaming cycles. First one I go in, I think 1.25 inches. The next one I go to depth, pecking every 50 thousandths. And then finally I measure my headspace and do my last measurement with feeler gauges, and then I set my headspace and we should be good to go. This one is the first time I've ever done a 33 Nosler for Defiance Action, so it's kind of trial by fire. I'm getting more and more confident in my drawing and my machine assignments, so hopefully when we push cycle start, everything will work out wonderfully and the program will work without fail. So next I'm going to take you over the machine, show you how we got her set up, show you the new spider chuck, the Omni adjustable spider chuck I got that we're going to be offering, and we'll get to work. So a lot of you guys I see online, people ask me, how do you flush the chamber? And I use a piece of hydraulic hose, and I actually use 1/8 inch pipe thread. I don't know where my tap is, but I tap them all with 1/8 inch pipe thread with the drill, and this screws directly into the barrel. I've tried many different adapters, and I ended up with many different leaks all over my shop floor. So this is just a rotary union. Goes in here like so. Clamps into place. This is adjustable on a rail. I cinch it down, and life is good. Now we can go cut. Still get a drip every once in a while. It's not that it has leaks. It's just sometimes a chip gets in there and can cause it to leak. Just part of the game when you're playing with chips and rubber O-rings. So if you're going to do it, always have a drip can ready, and you should be good to go. So this is a long stem indicator. I'm not a big fan because it wears out the joints right here from all the side load from being clear out there. But you can see how my mark's getting a little tired there, so I'll redo it. So if we go up to here inside the bore, that'll put our stylus right there, and then we can adjust our radial run out, and then we can go in another 3 inches or so and get our angular run out. I believe that we should always worry about what's going on in front of the chamber, not the back. And the reason I say that is we take a drill and a boring bar and we true up all this area to get it true with the bore that we're indicating. We wouldn't want to indicate here because we're going to cut all that away with the reamer, right? We want to get everything indicated at the throat and beyond. So we're just going to back this out, put this in here, and start indicating. I clean this barrel off camera so the bore's really clean. Some barrel companies, they don't clean them. No big deal, not talking smack on them. I'm just saying if you don't clean them, you can get some false readings. Another thing I want to show you here, if I can move you in, is make sure you're at the bottom of the barrel when you're doing this. So see how we're going to start riding up, and then we're going to go down, and we're going to start riding up again. We want to be in the middle of that drop. Otherwise what happens is your stylist rides up on the lands and you get some bogus readings. So we're going to back this off and we're going to rotate it and see how close we are. Get her closer to 0 here. So we're a few thou out, no big deal. So I just find the high spot, and going back to our spider chuck adapter here. This spider chuck adapter, these are my main adjustment bolts, okay, and these are my fine adjustment bolts. We get it close with these, and then when we try and, if we need to get that last couple tenths out, we do it with them. So if we just go to the high side here, there's the high side. I'm going to loosen everything up. We're going to loosen this coarse one up, and then we go to the opposite end, and then we lift. So we screw it in, and then we go back to the high side, and we loosen it up a little bit, and then we go back to the low side, and then we tighten it up a bit. Okay. So now we're closer already. So now we're going to split 0 again. Get the needle bouncing the same side as 0. Find the high spot. Here's the high spot. Loosen. Make sure this one's loose and this one's loose. And then we're going to go to the low spot. Oh, we're pretty close there. Okay, here's the high spot. We're going to loosen. Then we're going to come over here and we're going to tighten. Okay, and we're going to just keep going back and forth until we get her bouncing on 0. There's the high spot. There's a low spot. Alright, we're about a notch above either one of them. So now we got a radial indication pretty dang close. We're going to start using the fine adjustments like this. Cinch it up just a little bit more. Okay, we're bouncing on 0, so we're indicated radially right here. So now we're going to go in and we're going to adjust our angular. So our angular screws, when this is high, we got to push that down. So we're going to find the highest spots and push it down. There's a really high spot. We're just going to push this down towards 0. Okay, there's a high spot. I'm going to push this down towards 0. And if I can't push it far enough, I just loosen the bottom one, tighten the top. Alright, we're getting pretty close. And I like to measure directly off the lands. Then we know everything's true to the world. We're not wondering if we got a pilot that's out around or something giving us a false reading that you could have with other methods people use on the market. So we're getting pretty darn close there. So now we're going to go back to our radial adjustment to where we started. We're going to double check it. Okay, bouncing the same. We're going to go in, make sure this is pretty much spot on. So we're a little high there. Not much, just a little. I'm going to push this in just a little bit more. Alright, we got all that run out. So this is a pretty coarse adjustment. This is, I think I slid a feeler gauge on it. Each mark's about 1.5 thou to 2 thou. So now we're going to get a more accurate one that's in the tenths. And we're going to stick this bad boy in here. And we're going to indicate. So the throat is going to be clear up here. So we need this indicator shoved way up in there. And if you guys are doing this, be careful not to smash your indicators. I got like a drawer full of them that are ruined. So we can get pretty accurate with that other indicator. As you can see, we're pretty dang close. So we're going to get this bouncing on 0. It don't matter the number we get it bouncing on. We just want to make sure it's bouncing the same. So yeah, everything's bouncing perfectly. So we got that. Now I'm just going to go through here, make sure everything's snugged up so nothing moves. Because we don't want anything to move once we get her indicated. Alright, we're still bouncing on 0 or pretty dang close to it. We're just a little low in one spot. Right there. We're just going to cinch this up just a little. So now we got her dialed in so everything's bouncing identical. So now we got her set our G55 offset. And what that is just an offset I use to the face of the chuck. So all these tools over here, I'm going to zoom out here. Alrighty, we got everything set on our offsets. We're going to put our coolant right here. I'm going to run her fairly dry, and the reason being is I don't want coolant to get on the camera. It's my door. I'm cheating the system because I should have the door closed, but you guys probably want to see all this go down. I don't get a hurry when I do the first program or the first cut because stuff can go wrong plenty fast. We don't need to accelerate it. So this is our facing cut. It's going to cut it true. So now the computer and the lathe knows everything is going to be, all our measurements are go off that face. Try and get this so it doesn't make too big of a mess, but still makes it so it doesn't burn up our insert. So it should stop about a 1/4 inch away from the chuck. We'll speed it up now that we know that one's good. So when I make my tenon prints, I leave 10/1000ths oversize. And I always think, like, how is the chip going to be pulled? So now if we did this, we're going to have a burr right there. So we got to think about how to get rid of that burr. And how I get rid of the burr is pulling the chip the other direction. So this is our finishing pass, should be about 10/1000ths. So we're taking a 10/1000ths pass and we're pulling that chip this way, or that burr away from us. Then it's going to go in. This is where our recoil lug is going to be. That's where you see the two different sizes there. Just to ensure I got that burr taken care of, I just do another finish pass right there so we know this is nice and true and burr free. It's going to stop. And now we're going to start threading. So we'll stop it, we'll check our measurements. Good. Gonna push cycle start again and we're gonna thread. So with this chuck, I'm able to thread at 1200 RPM. That's something I wasn't able to do with my last system I was using. And you'll see it makes a beautiful thread. Most carbide tooling that we use isn't nearly as sharp as high-speed steel, and we need that speed to help make the cut happen. So that's cut. It's probably not to depth. I always fit the threads to the action if I have the action. So when threads are cut, they expand. Now I'm topping the thread just like we would with the topping insert. But I don't have enough room on this for every different thread, so I just top them with my profiling tool. And this is going to come back and just clean up that burr if there was one that tool would have made. So there it does 5 passes, 3 to depth, 1 finish pass. And then, like I said, this will probably be too... I don't think this is going to screw on because I oversize them, but we'll see. Yeah, well, usually I go about 3/1000ths over, but got lucky on this one. So, I got to take the bolt out because we haven't done our chamfer yet. So yeah, we fit. No play whatsoever, so life is good. Next thing we do is we got to drill our chamber, or pre-bore our chamber. So I'm going to do that with this drill bit. This drill bit knows where it's at in space to the chuck. It goes in here. We're going to cycle start. We're going to give it some coolant. I'll pause it here just so we get some coolant going. This is the first time I run the program, so I'm going to slow it down just so we don't crash. All right, it starts feeding to 0.2 inches before. So in all the cutting that we do while we chamber, the drilling cycle is the most aggressive, or can cause the most movement to the barrel, because it's kind of a form tool. So if you guys are doing this, if you're going to second check an op, After you get done drilling is the time to do it, and we'll do that once we're done drilling. So now we're done drilling. We're going to make sure the chuck didn't move, the barrel didn't move, nothing moved. And we do not want anything to move, because that will throw our barrel center out of concentricity with everything, and then we won't have a perfectly true chamber to the bore. But you can see 0 don't matter, but we'll just put it on there so you can see it. It's bouncing on the same, just like it was. So we'll take this off, and now we can bore our chamber. So memory, I'm just going down to our chambering profile. The reason I got to do that is because I canceled the program. So now we're going to go cycle start. I'm going to slow her down. So a couple things that always scare me when I'm doing this the first time. Once the program's proven, it doesn't really matter. But these boring bars are kind of expensive. And stuff can go, once you're inside a hole, it's easy to break off them little boring bars when we're cutting. So we want to start off slow, so if we programmed it wrong, even with simulation, we know we're not going to crash our boring bar into the machine and cost ourselves a lot of money. When we get to the end of this, it might be cutting a little more than I like. And I'll explain that when we start getting into the reaming. That's what I was talking about. The cone of the drill bit, I didn't quite go deep enough. And we got a little bit of a chip load there. I'm going to move her over. It's doing the counterbore now. So I'm going to shut her off here, and we'll come back to the finish pass after our counterbore is done. So now you can see everything's cleaned up, looking good. High RPM on threads just makes everything look so much better. You probably heard a little chatter or squeaking. You can see we got a beautiful finish on the counterbore. It's the size, it's the depth. I'm going to screw on the action, make sure it cycles up and down without any binding, and we should be set. Alright, so now we got the Omni adjustable reamer holder in the lathe here. And how this works is these 4 jacking screws point the reamer in every direction. Okay. We need to get the reamer perfectly in line with the bore that we got it indicated, which we do now. And then this reamer holder can go up and down. We use our X to adjust it front and back, and then voila, we got the reamer perfectly concentric to the bore. The reason this is so important is if we don't have the reamer perfectly in line, we're turning that reamer into a boring bar, and we can oversize the chamber. So this is our indication jig. These are 10th indicators, not thousands, so 0.0001. And if you guys buy one of these systems from us and you're struggling with the very front end, I mean, these pilots on these things have a bunch of play. You can see that movement. We're really concerned about this, and we're going to try and get this to indicate less than 2/10, which I did. We just sweep it around here, come back, and we're indicated. So now that the reamer is perfectly indicated to the bore of the barrel, which is indicated to the spindle of the machine, when the reamer comes in to start cutting, it'll follow our hole that's perfectly cut to the spindle of the machine with our boring bar, and it should go in, and we shouldn't get any chatter, and we shouldn't get any run out. One thing that I do on the first peck, and it's the main reason for it, is when we drill our counterbore, this pilot's not going to be in contact with anything, right? So we need something to absorb maybe a little bit of chatter if it happens when it starts cutting against that little 60-degree chamfer that I cut in there. And to do that, I just slide this like so over the reamer. And this is just to give it a little insulation when this shoulder comes in contact with the chamfer shoulder, so we don't get no chatter or squall right when it first touches. So we're going to push cycle start here. We're going to go in and out, and we're going to cut this chamber. I'm going to pause this here for a second. Get some fluid coming out of our barrel, like so. Alright, it's going to go in. Hopefully we'll start cutting here, which we did. Alright, there's our first peck. There was no squeak. There's no chatter. There's no nothing. Now it's going to start cutting a little faster. The machine's going to go faster. It'll speed up. And we're going to start cutting our pecks at 50 thousandths of an inch. Slow down just to make sure I don't crash it. Okay. I'm going to turn on the high pressure coolant. Whoa, that's a little too high there, Dustin. And now we're just going to cut the day away. So the chips and the strings will get a little bit bigger once we get to the spot of the chamber that hasn't been completely pre-drilled. I don't like to pre-drill too deep. We want that pilot to have something in contact with, and we should be pretty much there. And it'll just keep going in and out until we get our finished depth. Shy, probably about 20 thousandths shy, I hope, of finished depth, so we can set our headspace perfectly. We'll give it a little bit more pressure here. I give it full pressure, but I don't want to make a mess of the camera. And this is a prime example of why I use that cleaning patch to start so it doesn't chatter. It looks like this one tooth on this reamer right here is doing the majority of the cutting. And that's pretty common from all reamer manufacturers. One tooth is going to do most of your work a lot of times. And it'll change as we get deeper and deeper into the cut. And we're going 50 thousandths peck at a time. And just keeps on going until we're to the bottom. So I'm going to pause this. Just going to put you on a time lapse until we're done. We got her chambered here. I'm going to do a quick chamber inspection. Even though we have the flush, every once in a while we get a little chip that gets stuck in between there, and we don't want to waste our time. But the chamber looks good. Alright, we're going to put this on here, and hopefully our go gauge needs a little bit more work to get her closed. So here's our 33 Nosler go gauge. Go in and close. Alright, we're up against the shoulder, but we still got a gap. So now we're going to measure this gap. And this gap is 6, 12, 18's getting tight, 19 holds at 19, got everything sitting down. So now I'm going to adjust the offset in the computer to 19 plus 2, which is 21 thousandths. We're going to go 21 thousandths deeper, and then we should be perfectly headspace. So I'm going to go do that quick, and then we'll make our final cut. So I adjusted the work offsets in the computer. I'm going to put that in. Get some coolant flowing here. We only got to take a 21 thousandths cut. We're going to go in kind of slow. Turn on the high pressure flush here. It's going to go in 21 thousandths, dwell, and come out. Okay, we're cutting. Dwell, and now we're coming out. Yeah, we got that all blown out of there. So now we're going to take the action, we're going to screw it back on here. Now we should go with the go gauge. And we shouldn't go with the no-go gauge. So here's this. There's a go. Grab the no-go. And no-go, hard stop. So we got her perfectly headspaced on the first try. We'll give you a chamber inspection here in a second. And then we'll do a video of what the chamber looks like inside. Alright, here's a chamber inspection. We're bouncing. We can move it to 0. It don't matter. Bouncing good there. Then we come to the back. Now remember, this is the 33 Nosler Magnum case from front to back. We have no run out. No movement. I'll try and picture that. No movement. Okay. And then so you can see I'm touching. Come off. So you got a perfectly concentric chamber from front to back. Life is grand. Let's see what she looks like inside. So it's hard to see the screen taking a photo of a screen. You can see that everything turned out nice in the chamber. Here's the shoulder, up into the neck, and here's our lands. Got a little lag in that computer, but all the lands are perfectly uniform. all the leads perfectly uniform, and we've seen earlier on the indicator that that's all perfectly uniform. So we got a perfectly concentric chamber along with a beautiful looking chamber inside. So this is the 33 Nosler that you watch me chamber. It's on a Defiance Classic Action. Pretty sweet little action, pretty nice little build. But this is kind of showing off our carbon fiber wrapping that we do on Wilson blanks. Pretty proud of it. Taken me about 2 years to get to this point. As you can see, smooth, no real imperfections. It's a multi-layered system. We got, I think, 12 different layers of stuff in it. So, anywho's, we're gonna get this bad boy lasered, and then we'll put all the gadgets and gizmos on it. Next thing we're gonna do is throw the trigger on and assemble the chassis, and then bolt it all together. Trigger check, you went with the primary. Really nice triggers, can't beat them. I really like the diamonds. I run a 2-stage on my AR with a flat trigger, and I'm probably going to switch everything over to the flat trigger 2-stage. Pretty good feel. A little slack up the take, just because when out here when we're wearing gloves when it's cold, it's just nice to be able to feel something take up the slack. And then Ultradyne chassis. These things are pretty neat little chassis. They got an Arca Swiss 4-end, nice bottom metal, all included, and you can customize the snot out of them. And then he got an adaptive tack and an old adjustable buttstock, and I think he was going for a lightweight build. He got a see-through fancy Nancy handguard. So I'm gonna get her all thrown together, and we'll come back. Well, we got her all thrown together. Everything turned out great. We'll just talk to you about it from the front to back. We got a Wilson Arms blank that we used. We contour them down from a raw blank. They're double stress relieved and lapped. They've been great performers for us. We lay the carbon fiber ourselves. We take a multi-layered approach. We have 4 different layers giving it strength. And then this outer layer is just for machining purposes. It's a sacrificial layer just to make it all look smooth and pretty. Everybody's been pretty pleased with how our carbon fibers turned out and looks and shoots, so we're going to keep doing it. As of now, roughly 75% of the barrels that we send out are carbon wrapped, so it's been a good venture to get into. It's been frustrating. Thank you guys for the patience as we figured out the process. Excuse me. We do use a high temp resin to bond it to the stainless steel, and it's baked at 350 degrees, so some guys were asking me about that. The Aerodyne chassis, for the money they're steel. Excuse me. The only quirk I have with them, or this one, not all of them, is the set screw, or the screw that holds in the pistol grip. It needed cleaned out. The anodizing got a little thick and the bolt wouldn't go in, but I run a tap in it and that fixed that problem. The Trigger Tech trigger, pretty simple. Two pins in on a Defiance Action. There is no tuning with the trigger hanger. And what can you say bad about a Defiance Action? They're a sweet action. He just wanted to keep this thing as light as possible, so he went with the collapsible buttstock. He said he wanted to do some backpacking with it maybe, so just giving him a little less length to drag around. So yeah, everything turned out great. Super happy. Hopefully he'll send us some groups when he tells us how it performs. But anyways, thanks for watching. Thanks for the business. And as always, God bless.